are going to go over graphing systems of linear inequalities. These notes cover both section 3.3 and 3.4. We will go over section 3.4 on Monday. So, to graph a system of linear inequalities, remember a system is more than one equation or more than one inequality. So we are going to be graphing more than one inequality. So we will sketch the line for each inequality. Remember, when we are graphing an inequality, we have to shade the solution area. So we will then lightly shade the area that is the solution for each inequality. Then you will look to see where do all of the shadings intersect, and where they intersect is the solution for the system of inequalities. And you will want to darken that area in. So we are going to darken the solution area. Now there will be two types of solution areas. There will be a bounded region and there will be an unbounded region. A bounded region will be a solution area that takes on a particular shape, and it's closed off by lines on each side. An unbounded region does not have a line that closes off each side, and I will show you examples of both of those when we get to them. So our first problem, sketch the system of inequalities, shade the solution area. Those are your directions. So I notice that I have y is greater than 0. When there's only a y in my equation, that is either a horizontal or it is a vertical line. For y equals, that is a horizontal line. So that I don't have to do much with. That is going to be a horizontal line right here through 0. And I'm not going to shade just yet, but I'm going to think about where I'm going to shade. Y is greater than 0 means, well, to shade, I'm either going to be shading above the line or I'm going to be shading below the line. Above the line is all of the points greater than 0. So I'm just going to put a little arrow here to remind myself that my solution area is going to be up here in the top somewhere. Now, for my other two inequalities, I need to put those into slope-intercept form before I can sketch them. So I need to solve those for y. So pause the video, take a minute, and solve both of those for y. Okay, so I solved both of mine for y. The top equation, I subtracted the x, and so I had negative 6 minus x. I still had a negative in front of the y, so then I had to divide by negative 1. Remember, dividing by a negative, you flip the inequality sign, and then both of these signs changed. So I have y is less than 6 plus x. So if I want to graph this, this is my y-intercept, and my m is equal to 1. My slope is equal to 1. So I will come up here and I will plot 6. My slope is 1. So that means I will go up 1 to the right 1. And when I do these inequalities, I want to keep going until I can't go any further. So I went up and to the right. I can also go down into the left one. So I want to keep going until I can't go any further, or until I hit the other line that is drawn. Then it would probably be best to use a ruler, and I have rulers up in the front of my classroom next to my podium on the short little cart. So use a ruler, draw your line. So this is my, I'm going to put a number 1 by this. This is my first line right there. Okay, now I need to figure out where to shade. So if I do the 0, 0 test, I get 0 is less than or equal to 6. Is that a true or a false statement? That is a true statement, which means 0 is a solution to my system of equations. So I want to shade the side of the graph where 0 is. This is the side that 0 is. So I'm just going to lightly shade all of this. Now, I'm going to be doing these lines in different colors. You may want to use different colors also. It might be easier for you to find the solution area if you use different colors. My next equation, x plus y is less than or equal to 6. I put that in slope-intercept form down here, and I get y is less than 6 minus x. So again, b is 6. This time m is a negative 1. So here's 6. Negative 1 means I go down into the right one. So I'm going to keep doing that. Or I could go up into the left one. And I'm going to go ahead and draw this line. And so this will be line number 2, so I'll put a number 2 by it to remind me that that's line number 2. And if I do the 0, 0 test, I get 0 is less than or equal to 6, which again is a true statement, so that means 0 is a solution. So here's where 0 is. So I'm shading on this side of the green line. Now if you recall, I put this y equals 0 line in there, but I hadn't shaded yet, but I put arrows over here to show that I'm going to be shading above the line. So if I shaded above the y-axis, or excuse me, above the x-axis, and then I have the green shading and I have the red shading, I want to look to see where all of my shading intersects. Right now the red and the green intersects in here, and all this whole big area here. And if I didn't have this y equals 0 line, this whole area all the way down and keep going down, that would be my solution area, and that would be an unbounded region. But because I have y is greater than 0, I only want above the x-axis, which is this triangle in here. Because I am in the green area, I'm in the red area this way, and then I'm above the x-axis. This is a bounded region because I have lines on each side. And that's my solution area. I darkened it, and I'm done with that problem. Okay, the next problem. I have x is greater than negative 1. Well, there's only an x in it, which tells me it's a vertical line. It's a vertical line through negative 1. So I will come over here, and I will draw a vertical line through negative 1. That's my first graph. Greater than negative 1, I'm going to be shading everything to the right. Everything over here to the right. I'm going to try to do it lightly since I have a pen. Everything over here to the right is shaded. That's greater than negative 1. Okay, my next line. Y is less than 4. So this will do line number 2. It only has a y, which tells me that it is a horizontal line, and it's a horizontal line through 4. Now, it's just a less than, which tells me it is a dashed line. Well, I'm going to go ahead and draw a solid line, so it'll show up better, but then right next to it, I'm just going to say that that should be dashed. And it says less than 4. Well, is that above the line or is that below the line? It is below the line, so I'm going to shade everything below the line. So if all I had was line number 1 and line number 2, if all I had was the blue and the green line, can you tell where the shading intersects? The shading intersects in this area right here. But I have a third line to graph. So we need to put that into slope-intercept form. So go ahead and put that into slope-intercept form and graph your line. Okay, I put this in slope-intercept form by subtracting the 2x. Then I divided by negative 1. Remember, dividing by a negative flips the inequality sign and changes the signs on both of your terms. So we have y is greater than 2x, or excuse me, 2 plus 2x. So my slope is 2 and my y-intercept is 2. So I came over here and I graphed it. My y-intercept is 2, and then I go up 2 to the right 1. Or I could go down 2 to the left 1. So I did that a couple times. I wrote dash next to it because, again, this is supposed to be a dash line. If I do the 0, 0 test, I get 0 is greater than 2. Is 0 greater than 2? Hopefully you said no. So that means 0 is not a solution. So here's where 0 is. But if it's not a solution, I have to shade where 0 is not, which means I need to shade everything on this other side of my red line. So now I need to figure out where does my red, my blue, and my green intersect. Well, I was below the green and I was to the right of the blue, which means I was in this area here where my hand is. So I was somewhere in here. Then I put my diagonal line in here, and my red is in this area that includes both the green and the blue. So that little triangle, that little sliver, is the solution for that system of equations. So make sure you darken that so that we can tell that that's the solution area. That completes our 3.3 notes. The rest of this note sheet we will do on Monday, section 3.4. You should have enough information now to work on your 3.3 assignment. That assignment will be due on Tuesday.